What is potential infinity? Potential infinity is indeed a familiar notion. We are familiar with this kind of infinity. When we start counting the numbers, the natural numbers, 1, 2, 3, 4, 5, and you go on by adding one by one successively, 6, 7, 8, without stopping, we say you will arrive at infinity. But indeed, there is no infinity you can arrive. It is not a fixed stop somewhere waiting for you. You can never reach that infinity. The numbers go to the infinity, as the saying goes, but that infinity is not a real infinity. It is not a fixed number. It is not something that all the numbers, all the counting numbers stop. There is no such an end. What they mean by infinity here is, if you count one by one without stopping, you can go forever. There is no point you can stop, but there is no end point. There is no definite infinity you can reach either. Therefore, this infinity, this type of infinity is called also variable finite, and shown with this kind of 8 number. You can see the 8 is differently turned here. It's the symbol of potential infinity or variable finite. It refers to a procedure that gets closer and closer to, but never quite reaches an infinite end. It's not a real infinity. But when people use the term actual infinity, they mean true infinity, the real infinity, which is shown with this symbol. It's called Aleph 0, the first infinity of actual order. It refers to an already complete, infinite, timeless infinite. You may think about this actual infinity as a set that has infinitely many elements. Okay? Like the number of elements in the set of natural numbers. They are there without adding or subtracting something. There is no process here. You don't add something. You do not increase the number of elements in time. It's there. That's it. This set has infinitely many number of elements. This is true infinity. This is actual infinity. It's fixed number. Its number is fixed. Okay? And infinite. It's very hard to understand. This idea is very hard to imagine, very hard to understand. And many people rejected it since Aristotle. Aristotle accepts potential infinity, but doesn't accept actual infinity. Nobody in medieval philosophy, as far as I know, accept actual infinity. It's, unimaginable idea, okay? But some modern philosophers and Cantor accepts actual infinity. And Cantor bases the set theory on the base of this actual infinity. And the mathematicians today like this idea because it makes life easier. Math, conceived within this framework, is much easier to do and much effective. So they do not want to leave it or reject it. So if you reject actual infinity today, you have a big problem with the mathematicians. Okay? Therefore, Craig doesn't reject actual infinity completely, but reject the idea of applying actual infinity to concrete reality, like Taftazani. Okay? That's the difference. Abdul Rahman asks, Aristotle accepts and the infinite regress of events is not that considered an actual infinity. No, Aristotle accepts infinite time, past time, but it is not actual infinity according to Aristotle. He considers it potential infinity. Neither Ibn Sina considers it actual infinity. They all consider it potential infinity. Al-Ghazali's objections to them is exactly in this point, on this point. Al-Ghazali says, past events, if you think they are infinite, they cannot be potentially infinite. They must be actually infinite. Even that you cannot accept. This is the objection Al-Ghazali brought to the philosopher. Is there a problem if we say Allah can create instantaneously an infinite number of planets? This is the question from Abdul Haq. There is a problem. If you think like the Mutakallimun consider actual infinity in concrete reality to be a metaphysical impossibility that doesn't fall within the scope of divine power. Okay, it's impossibility. You cannot say God can create that. But this is about actual infinity applied to concrete reality. And your example about the infinite number of planets is an infinite number of concrete things, not infinite number of numbers. Okay? In that sense, the Mutakallimun would reject your proposal. Okay? Let's continue. A proper subset is a subset that does not exhaust all the members of the original set. The set of even numbers, for example, is a subset of natural numbers. Equivalence means they are the two sets that they are equivalent if their members can be put one-to-one correspondence. What is one-to-one correspondence? Okay, take two sets like 1, 2, 3, 4, the elements of one set, y, w, x, y, z, the elements of the second set. You can, as you see here, you can relate 1 to w, 2 to x, 3 to y, 4 to z, and no element is remained alone. All of them are connected to each other. This is one-to-one correspondence. Okay? An infinite set is defined as infinite if it has a proper subset that is equivalent to itself. This is a very, very weird and interesting idea. Consider the set of natural numbers and the set of even numbers. The natural numbers, 1, 2, 3, 4, and so on, could be put into one-to-one correspondence with the even numbers, with the elements of even numbers. For example, 1 could be related with 2, 2 could be related with 4, 3 could be related with 6, 4 with 8, and so on, n to 2n. With that formula, you can relate all the numbers in natural numbers to the even numbers. Therefore, you can show with this that even numbers is also an infinite set. Cantor's set theory, we talk about the cardinality or size of a set here, which is a measure of the number of the elements of a set. For example, the cardinality of natural numbers is the smallest transfinite number, which includes infinity, which is shown by LF0. Okay, the size of natural numbers is the smallest of infinity, and there is a hierarchy of infinity. There is bigger infinities than natural numbers, and there are also infinities that are equal to natural numbers, like even numbers. But real numbers is not equal to natural numbers. It's greater than natural numbers. So we call denumerable or countable infinite sets the sets which are equivalent to natural numbers, because we can count them one by one. They can be put one-to-one correspondence with natural numbers. Rational numbers are shown to be equivalent with natural numbers by Cantor, but real numbers are not. Since real numbers include more than rational numbers, like square root, 2, etc., its cardinality is greater than natural numbers. And we show it with Aleph 1. It's an uncountable infinite. But natural numbers are countable infinite. Rational numbers are countable infinite. They are both Aleph 0. And there is a hierarchy of infinity. If you take the power set of a infinity, it is always greater than that set. For example, Aleph 0 is the smallest. Aleph 1 is greater than Aleph 0. Aleph 2, the power set of Aleph 1, is greater than Aleph 1. There is a hierarchy of infinity in this context. Now we can do arithmetic with transfinite numbers. For example, you can add any natural number to Aleph 0, but you get Aleph 0 at the end. For example, Aleph 0, the infinity of natural numbers, plus, for example, say 5 is again Aleph 0, equal to Aleph 0. Aleph 0 plus Aleph 0 is again Aleph 0. Aleph 0 plus Aleph 0 plus Aleph 0 plus Aleph 0 is again Aleph 0. Aleph 0 plus Aleph 1 is Aleph 1. Aleph 1 plus Aleph 1 is Aleph 1. But we cannot do subtraction with transfinite numbers. Why? Because the same mathematical equation will give you different results. For example, when you subtract Aleph 0 from Aleph 0, on one occasion you will get n, on another Aleph 0. Because remember from this earlier calculations here, the first two lines here in parentheses, Aleph 0 plus n equals Aleph 0. If you move Aleph 0 on the left, it comes with subtraction n. If you move Aleph 0 on the left of n, which is in red ink, to the right side of the equation, you will get n equals Aleph 0 minus Aleph 0. But if you move Aleph 0 in the second parenthesis to the right side of the equation, you get Aleph 0 equals Aleph 0 minus Aleph 0. You do the same calculation. You subtract Aleph 0 from Aleph 0, but you get two different results. This is unacceptable in mathematics. It's undefined. Therefore, subtraction is not allowed within the arithmetic with transfinite numbers. Okay, keep this point in mind. It would be important. But remember what I said. Craig or Al-Taftazani do not accept actual infinity applied as concrete to concrete reality. Why? Because there are some problems appearing when you apply actual infinity to concrete reality. And we will exemplify these problems in the famous example of Hilbert Hotel. This is a very interesting hotel which has infinitely many rooms. Okay, imagine a hotel which has infinitely many rooms. It's a very weird idea. You can imagine it. You can't imagine it. But just consider it as an example. They are full. As it happens, one day you visit Hilbert Hotel, but the receptionist says all rooms are full. But you insist, give me one room. And you give some money extra to the receptionist. He say, okay, I can arrange something and see what happens. The receptionist makes the following arrangement. Look at to the left. There are two sets here, you can see. The infinite room, the infinite hotel on the left when it was full, and the infinite hotel when you can enter into the first room. How does the receptionist empty the first room? By moving the person in the first room to the second, the person in the second to the third, the person in the third to the fourth, and so forth. He moves everybody in the existent rooms to the one room successive, okay? Second to the third, third to the fourth, etc. And you can arrange this way. All people replaced are replaced, and the first room becomes vacant. Now you can enter the first room. This is possible in an Hilbert Hotel. Okay? Now, imagine an infinite number of people visited the Hilbert Hotel. The receptionist even put these people into the full Hilbert Hotel, an infinite number of people. How? He can move the person in the first room to the second, the person in the second room to the fourth, the third to the sixth, fourth to the eighth, etc. This way, the rooms 1, 3, 5, 7, and etc. will be open, and he can move the guest into these rooms. However, recall that I said you cannot do subtraction in transfinite arithmetics. It is not defined, it is not allowed. But what if some people leave the hotel? What kind of calculations you will do here? You will subtract those numbers from the present people. You cannot say, it is not defined, I cannot do that. It is defined now. In concrete reality, you have to subtract and deal with subtraction in an infinite, transfinite context. Now we assume the people in the odd-numbered rooms left the hotel. As a result, the half of the hotel was emptied. Right? Despite this, the number of guests in the hotel remains the same. They are infinite. By moving the guest in room 2 to 1, the one in the room 4 to 2, the one in the room 6 to room 3, the hotel can be filled again. So the same hotel was both empty and the full. Half empty and the full. Let's assume that guests staying in rooms number greater than 3 left the hotel. In this case, only 3 guests will remain in the hotel. The hotel has suddenly emptied, and there is no longer any possibility to fill the hotel by changing the guests' places. However, strangely enough, the number of guests leaving the hotel is equal to the situation where guests staying in odd-number hotels left. Both are infinite. These two groups can be paired 1-to-1, so it can even be thought that actually the same people left the hotel. So, when you start doing subtraction, you get contradictory and very absurd results out of your calculations. And you cannot say it is undefined with respect to Hilbert Hotel because people enter the hotel as well as leave the hotel. you must consider the people leaving the hotel now. So infinite roomed hotels and systems with common features to this hotel cannot exist. In this thought experiment, the feature leading to the absurd conclusion is not just the actual existence of infinite guests, but the fact that these guests have a position in space and time. They are their entities that can move, removed, and added. And the idea behind the Delil al-Hudus is that, as formulated by Taftazani and Craig, the sequence of infinitely past events is exactly the same as Hilbert Hotel. So past events form an actual infinity in concreto. It is not potential. Some objections come and also discussed from the Aristotelian side, stating that the past would be potential because it doesn't exist. If it is infinite, it must be potential because the past doesn't exist. But right now, even if you accept the past doesn't exist, still you have a problem, because the past events could be numbered or recorded, even if they do not exist. For example, the number of solar eclipses so far. Consider the arguments of Al-Ghazali, who gave against the philosophy. The revolution of, for example, the Earth around the Sun and the revolutions of the Jupiter around the Sun. So he says the revolution of Sun around the Earth and the revolution of Jupiter around the Earth because it was the geocentric system. But if we apply the same example to contemporary astronomy, we can say the world's revolution around the Sun and the Jupiter's revolution around the Sun. These are events that could be recorded and numbered. How many times the world, the Earth revolved around the Sun and the Jupiter around the Sun. And there is a proportion about this revolution. Al-Ghazali stated it was 1 to 30, the revolution of Sun around the Earth and the revolution of Saturn around the Earth was the 1 to 30. But both of them are infinite in your view. What kind of infinity is this? One is 30 times greater than the other, Al-Ghazali says. Kantorians could respond to this objection because they can put one-to-one correspondence with the infinity of the revolution of Sun around the Earth and with the infinity of the revolution of Saturn around the Earth. 1n to n goes to 30n. Kantorian mathematics can explain this. But the point is not just the infinity. It is infinity in time and space that you can relate to the Hilbert Hotel example. You can do it there, subtraction and difference appears. And then you can see the absurd conclusions. Since this applies to concrete reality and the past or events are concrete, although they do not exist right now, they could be recorded and that is enough for their actual infinity. They form an actual infinite class according to Craig. Is there any question so far? How can we know it's equivalent? Equivalence is known by one-to-one correspondence. They are sets of infinite numbers that are so big that they include other sets of infinite. Yes, natural numbers include even numbers or odd numbers. So you may see in ancient texts that the part of something cannot be greater than the whole. This idea doesn't work here in Cantorian set theory. The even numbers, could be equal to natural numbers, which is whole, greater, how to say, but it is not greater according to one-to-one correspondence. So in mathematics, this idea doesn't work within the context of Cantorian set theory. But in concrete reality, the case is different. The second argument is about forming an actual infinity. Here, we do not argue from the impossibility of actual infinity, but constructing an actual infinity. Craig says, even forming the actual infinity, forming a collection of actual infinity is impossible. Why? Because the temporal series of events is a collection formed by successive addition, the first premise. And any collection formed by successive addition cannot be an actual infinite. Because you remember potential infinity. You have you increase the number one by one by adding something to earlier segments. Actual infinity is something fixed. You cannot increase it like that. And therefore, the temporal series of events cannot be an actual infinity. Here, this argument was criticized by assuming that time is dynamic. It's a flow. It's, there is a discussion about the nature of time in contemporary metaphysics. What is the real nature of time? Is it a flow? Is it dynamic, or called tense theory of time, or it's static? Past, future, and present exist all together. Past is just one region of the same space-time block, but it exists like the present. This is called tenseless theory of time, static theory of time. If you assume the static theory of time, this argument may not work. And for that reason, Craig wrote many academic books to argue that time's nature is not static, it's dynamic. Okay? Okay. And also, there are additional scientific arguments Craig considers. One of them especially concerns the Big Bang and the expansion of the universe. The other one concerns the second law of thermodynamics. But as I said, I will not be able to cover those arguments, maybe some other time on some other occasion. You may learn about these arguments. As for your reference, you may look at these books to get an idea about the Kalam cosmological argument as formulated and defended by Craig, and also discussed in the literature. The Kalam cosmological argument is the first book here on the left above. Then Craig edited 2 books by Bloomsbury on the Kalam cosmological argument by chapters written by various scholars. The first book is about the philosophical arguments. The second book is about the scientific evidence. And then there is a recent book by Jacobus Erasmus, The Kalam Cosmological Argument, a Reassessment, and also Andrew Luke has several publications on this issue. The book at the bottom in the middle, The Teleological and Kalam Cosmological Arguments Revisited, is a nice book. You may look at it. And Mark Nowak's The Kalam Cosmological Argument for God is another book you may consult. Okay, thanks very much for listening to me. And if you have any questions, I would be happy to answer them. Okay, Murtada Sunny. Alaikum salam.
How do we respond to the second part of the argument, that is showing that the cause is a personal agent and also there are not multiple causes, using the Kalam cosmological argument?
So the second part of the argument you are asking about, why the ultimate cause is a volitional agent. So the Mutakallimun usually appeal to the features of contingency and order in the universe to argue, to make that point. Because remember, contingency requires a cause. But a multitude feature in contingent reality must be selected. Selection could be done only by a willful agent. And also there is an order, a definite order. If you leave this pen, it falls down. It doesn't go up or this way or that way. There is a definite order of its motion. Why this way, not that way or this way or that way, or always repeating the same pattern? This requires will and knowledge, they say. Okay? There are many discussions in mathematics about infinity that don't deal with concrete cosmological metaphysics. So we don't have to enter in such complete discussion to be able to make our argument. Anybody wanting us to talk about that is making a straw man. Okay, if you say, or you need to show why the mathematical infinity, or how to say, why mathematical Cantorian transfinite arithmetic or set theory is not valid in concrete reality. You need to show that. This is your burden of proof. It's on your shoulders to show why Cantorian set theory does not apply to concrete reality. Okay? What if the order was defined by the natural laws of nature? Okay, no problem. Why there is a natural law about motion? The ultimate cause of the universe must know that this is the law of nature, not something else. We can use the example of hotel, but it's quite hard to understand. Okay, it may take some time to digest the material, but it's not too hard. Okay? Just a little bit thinking. Okay? Anything else? Inshallah. Evet. Okay. Okay, guys, thanks for your patience and interest. I hope the presentation would be useful for you, and you may appeal to these sources to enlarge your knowledge. How about the one of the ultimate cause, the uniqueness proof? I wrote some papers on this issue, and one more chapter in the upcoming Islamic philosophy, analytic philosophy of religion by Routledge, in which I examine this issue in detail. It will be published in December this year. If you are curious about this issue of divine uniqueness, maybe you can look at that chapter in the book. Okay, guys, thank you very much. It was nice to talk about the Kalam cosmological argument and chat with you. Have a nice day. I hope you enjoyed the lecture.